Hello and welcome everyone. My name is Maralina Ungur. I'm a learning consultant at EUMETSAT, the European Organization for the Monitoring of Meteorological Satellites. I am joining today's session from my mobile phone. I hope you can all hear me well. I'm very excited to host this session on satellite skills training online with Mark Higgins. Mark is my colleague at EUMETSAT. He is a training manager, an avid supporter of online learning, someone who can, how can I say this, spot very well the opportunities within a crisis, such as the one we are all living nowadays. But he will tell you about this and a lot more about online learning and teaching satellite skills in a moment. Now, before we start, and I hand it over to Mark, I would like to mention a few practical aspects about today's session. Our colleague Rosa is supporting the session from a technical perspective. Thank you very much, Rosa. So if you believe at any point that you're experiencing audio problems, please search for support in the participants list. Send a private message to support and Rosa will try to help you. We are recording today's session. We will not be using video, so please try to keep your videos off. The microphones will also be muted until the last part of the session. However, we are inviting you to post your comments, to give us feedback and answer a few questions that my colleague Mark will be posting in Slido. Slido is a very nice online tool, and we invite you to go to slido.com, slido.com, Slido, and join the session if you haven't done so already using the code EUMETSAT3. We will have this information on every slide, I think, for you, and we'll also be posting in the chat. You can join us from your phone as well. Be on Slido on your phone, watch the presentation on your computer. Finally, the slides, the recording, and other useful resources will be they're already available for you on Moodle. Moodle is our training platform where you registered for this session. That's training.eumetsat.int. We will also email you later on about it, so you'll be able to find the slides of this presentation and other recordings and useful resources for you. We are also trying to use subtitles for this session in case the audio might be problematic. We'll see how that one goes. So that's all from my side. I'll hear you towards the end of the session. Mark, hi and welcome. Are you ready?
I am, yes. Hi there, Madalena. And hello and welcome to all of you. Yeah, so we are using the PowerPoint embedded subtitles tool today. So we'll see how that goes. I'm a native English speaker, so I can sometimes talk very quickly, so this will also help me to slow down. So the session today is looking at teaching skills online. And particularly, I'm focusing on skills-based teaching. So some of our training, we're teaching more theoretical knowledge. But in this particular presentation, I'm going to focus on skills. So, as Madalena has said, we're going to be using slido.com for the Q&A, for questions and answers. But as we go along, you may also want to post examples from your own work of good teaching. And if you wish to do that, post it with an X. Otherwise, post questions. If you like to, put a #Q in front of a question. And we'll have some time as we go through the presentation to do a little bit of Q&A. And at the end of the session, we'll have a lot more time available as well. So this is my starting point, the big scream. And the scream is this. Some of the courses that we come across, we see plenty of online resources being offered to the learner. And we get them to look at resources, to look at PowerPoints, to read case studies, to read papers, maybe watch a video. Then we'll do a quiz to test that they've learned something. Then we'll ask them, how did you do? Did you find that nice? And that's it. Now, this is quite a commonplace approach in many of our online learning environments. And unless you're training for short-term recall, so being able to recall facts, this may be an ineffective approach. So what we're after, of course, is this. Joy and fireworks. What we're after is something slightly different, where students have actually got the opportunity to learn a skill, to be able to do something differently in their working life. So what I'm going to do in this presentation is talk through a framework. It's from a guy called David Merril, and it's a framework that helps structure our learning. I think it's particularly relevant or useful in these times as many of us are looking at teaching online, because it helps us to design the right online experience for different points in the process. Now, for those of you who had a look at the Moodle site before this presentation, you would have seen there was a short questionnaire, and we asked you if you'd seen Merrill's principles before. Most of you hadn't done, but some of you are taking the time to have a look at the paper, and one or two of you also have got teaching experiences from other classrooms or working with school-age kids, where these kind of principles are used a lot more strongly. So this might be a new framework for many of us. So I'm going to go through it a little bit slowly and show some of the examples from EUMETSAT's practice. So this is the basic outline of the whole thing. So Merrill's 5 principles. Good thing happen. In other words, learning. Now, he frames it as learning is really well facilitated, or learning can happen when. So when you teach with real world problems, so what that means is we're actually working with the challenges that our students actually face in their working lives. So working with the real world context and the real challenges that they face. We won't be covering learning objectives so much in this session today, but this is where your learning objectives also really matter. Do they actually connect to the real world problems that your students face? And then the following 4 points offer almost a flow of things that might happen in a classroom. And that classroom can, of course, be online or a real physical classroom. So the first step is that the students' knowledge, what they have already, their skills and knowledge, you're building on that. And the first step is to actually activate what they already know. So in other words, to get the students to actually use the skills and knowledge they have, and to recognize what they do and don't know, or what they can and can't do already. Then you're going to demonstrate the new skills and knowledge. So actually show them what they're going to do. They will then apply it. That's the fun part, watching people actually play and develop and learn the new skills and actually make it their own. And then they're going to integrate those new skills into their day job. And some of that will be in the classroom, and some of that may be after the classroom environment. So let's start with the real world problems. So this might also be a real world problem that some of us are familiar with, the assembly of flat packed furniture, the sort of classical challenge. But what is a problem? So in this context, it's a task. It's something that the learner will encounter in the real world. And problems by their nature are complex from the beginning. Often there are indeed multiple small tasks that relate and fit together. And we need to teach each of the elements and the integration. And this is one part that we maybe sometimes forget in many of our courses, is this integration step. So we may teach people to do one step, then another, but we may forget to help people put stuff together. In forecasting courses, of course, this is a big part of the process, helping students to put together all the meteorological knowledge they have so that they can then analyze the environment, produce a useful piece of information, and then communicate that information to a customer. And of course, the learning objectives will directly relate back to the problems that we're trying to address in our course. So here we go. Here's a poll. This is the first of our poll. Be honest. Do your courses really deal with real world problems. Let's see how we do as a community. The poll is anonymous, so it's open now. So if you go to slido.com and the code will be, there we go. So we can see the code there. The code is EUMSC3. So answer away. Do be honest. Okay, so go to slido.com and the code, if you're wanting to get in, is EUMSC3. Okay. Take another 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. So Rosa, if you wouldn't mind to show the results. Aha! Mostly would be the strongest sense for us. Some of us, our focus is on simple cases. 20% of us, we're always working with real world problems. And 15% of us, the focus is on learning the theory and the background theory. Now, this question isn't meant to be a judgment. This is for something actually for you to think about. Do you have the right balance for your courses? Are you maybe teaching too much theory or too much small steps within the problem or the whole problem? So it's something for you to consider for yourself. So that's a question for your own courses is, am I teaching the problems that my students really need to follow? So let's skip back over to the slides. So here's some example problems. Forecasting fog for an airport. So in this kind of course, we would be looking at the whole meteorological background that we'd need to understand fog, its formation, how we would analyze it, the observations we might need to actually diagnose fog and its formation and then dispersal, how we might actually go about forecasting it, what data we might use for that, the role of numerical weather prediction, for example. And once we've actually got our forecast, how we might communicate it, either through some form of verbal or written communication or a more formal communication like a TAF. Or we might be wanting to identify cumulonimbus clouds, their intensity, their organization, and their stage in development. Now, if you go to the Moodle site and download the slides, you'll actually notice this is a link. And it's a link to the WMO skills document that describes a whole series of satellite skills. So if you're designing a satellite-based course and you're wondering what problems you might work on, you've actually effectively got a list of problems there, a list of skills that people have to have in order to use satellite data in meteorological forecasting. Another thing we come across a lot of with working with satellite data is actually how to read the data. The data are quite often non-trivial, and you have to get it into X-array if you're using Python, or a data frame if you're using R, or some other structure if you're using Fortran, C, or Julia. So actually being able to do this is an important skill for a lot of people's scientific programming. And we could actually just have a learning objective that's around this, and this would be the problem, how to read the satellite data. Or we might be comparing two data sets. We might be doing that programmatically, so actually calculating differences in statistics, and actually this would be a programming or a scripting course, how to actually do this. Or we might be thinking about this scientifically, so actually testing a theory and explaining the data. Why are these two data sets the way they are? Why do they differ the way they do? Or in fact, we may be doing both. And this would be an example of, say, a climatology course where we would be teaching both sides of this challenge, working with, say, satellite climate data sets, calculating differences in statistics, calculating anomalies, and then understanding and explaining the data. And actually, this whole integration is the challenge of that course. So these are real world problems. It's something the learner will encounter in the real world, and they are complex from the beginning. So here's an example of something, I don't think it's a problem. Describe the spectral response of a particular channel. So quite often in some of my courses, I may have done this, okay? This is one of my learning objectives. You're going to be able to describe the spectral response of a channel. You're going to be able to describe how a channel responds and what it's able to sense. And I've come to the idea that this isn't really a problem because it's isolated and it lacks context and it needs some context. Why are we doing this? Why are we wanting to look at this particular satellite channel? Well, maybe it's because we're trying to detect something. So, for example, dust. If I'm trying to detect dust in the atmosphere, what satellite channels might I use? Now I have a problem. And now I can start to explore how different spectral response functions might respond to dust, and therefore what kind of channels I might use to detect dust. So I might be doing pretty much the same thing in my course if I'm playing with spectral response functions, but now my problem is much more focused on what my participants, what my students are actually wanting to achieve. And this is quite an important step. So this is the kind of underlying principle that sits underneath what Merril is working with. So we're teaching with real world problems. So now let's actually start teaching. And our first step is building on what the students already know. So what the students already know is activated. This is the first thing we're going to do in our classroom and built upon as a foundation for the skills and knowledge. So this is kind of lighting up your classroom, getting things going. Now, when I say classroom, I'm of course talking about online and face-to-face environments and synchronous and asynchronous. So courses where the interaction is happening at the same time or courses where interactions are happening at different times over the course of the course. So what we're doing is we're finding out what the students already have in terms of knowledge and skills, and we're building on that. So they're going to be doing things like recalling or relating or describing or applying their knowledge. And they're going to apply it to the individual elements of the training, so the little subtasks, and also the integration of all of that. So here's some examples of things you might do. You may do a pre-course quiz or self-assessment. You might get people to develop a concept map or write down a checklist. So for example, if we were doing the fog forecasting example, we could say, okay, please, as part of your work at this stage of the course, provide a checklist for your fog forecasting. And in that, we will then know from the students what they know already, what they don't know. And with both of these kind of things, the pre-course quiz and self-assessment and the checklist, you can also ask the students to reflect on their current knowledge. So when they wrote the checklist, were there particular elements they felt very comfortable with, very convinced by, or very certain with, or elements that they felt much less convinced by or much less certain on? We can also have group tasks, so maybe do a current weather exercise, actually forecast some fog, again, drawing the conceptual map or a checklist, sharing some examples in a Padlet or a forum or a chat, or using cues and questions. So cues is asking, if I'm at this stage in the process, what do I do now? If I see this in an image, a satellite image, what do I do now? And you're getting the students to respond. And right at the very beginning, there will now start to be what we call artifacts. So the students will start to produce stuff. And this can all be produced online and shared. So you can use things like the Padlet, and there's an example of a Padlet in the Moodle course, or using a forum or in a chat. And all of this is about getting the students to know what they know already and can do already, and also so that you can start to connect what they know and what they can do already. So let's see if you've got some ideas. So the poll is open now. If you go to slido.com, there's a bit of a word cloud exercise. And so if you go, code again is EUMETSAT. Just drop down some ideas about what kind of artifacts might get produced in the activation step. What kind of things might you see in your classroom, online or in a classroom, a physical classroom, during this step? So have a think about this. I'll give you 30 seconds to think about it and get some answers in. All right, take another few seconds. I'll count down again. 10, 9, 8, 7, 6. And don't worry if you can't think of anything. The reason for doing the poll is also so that we can sort of see the ideas that people might have. 3, 2, 1. Right, Rosa, if you don't mind showing, see what people have for the activation steps. Maps. Maps in the beginning. Love a bit of maps. Early warning system, list of keyword forecast examples, word cloud, tables, drawings, mind maps, question marks, flowcharts, questions. Love questions. To actually get the students to write down their questions will also tell you what they do and don't know, because the framing of the question will give you some sense of where they're at. Tables, flip charts. Yeah, if we're in a classroom, I really like having flip chart up in the wall because it gives you a visual history of what's going on. And I also quite like to do that if I can in the online environment. So if you're using forums or if you're doing something in Moodle, so that people can follow what's happened. Unit mismatches, essays, methods. Yeah. This is exactly the kind of thing. I'm loving also seeing maps in big letters in the middle. Quite a lot of what we do, of course, in meteorology and environmental science involves a geospatial understanding. So connecting the flow of the atmosphere or the ocean to some driving forces or some synoptic conceptual models and things like that. Excellent. Thank you very much for those. What we'll do is we'll take a screenshot of that and we'll put it in the Moodle site for the future so that we can start to build up our own visual record. All right. Yeah. So this is one example. This is something from a course. So this was using a tool that we've got in EUMETSAT so that people can view and then annotate an image online. So this is from a jet streams example, somebody annotating and looking at what might be going on with jet stream. And in this kind of example, what I'd be doing with the student is asking them, when you drew those lines, explain to me why you drew them where you did. So you can actually get under the skin of what they do and don't know. Again, we might be doing some stuff. So very simplistically, this was a Southern Africa conceptual models class. So looking at just highs and lows and how they might be driving synaptic patterns. And then a more sort of formalized description. So actually you could use this to have a forum discussion or a live synchronous discussion in something like Zoom, the monsoon example. And in that discussion, what you'd be looking for is getting the students to identify when they do and don't feel comfortable, when are they confident and less confident, what questions they have. And this can be really motivating because what you're going to be doing is connecting the students to the rest of the course that follows and giving them some motivation as to why they want to do the rest of the course. We often skip over or simplify this step. It's not abstract or pre-course knowledge, it's part of the training. And we do need to focus on what's important. Very strongly suggest to not go into what's unusual. That's a slightly different course when you're going into different depths, but stay with what's important for the skill you're trying to teach. Pre-tests are great, but make sure you're letting the student also reflect on what they know and setting up the test so that students aren't frustrated by the failure. Because ideally, if the student gets everything right, they may be in the wrong course. So they should be getting some stuff wrong. They'll be making mistakes. And that is okay at this point, very much okay. And they need to know that. You may actually also need to provide some learning experiences if you've got more teaching to do to actually get your students up to the level they need to actually do your course. And the knowledge and skills and the map of how it all fits together and how it's organized can be really helpful. So not only are these meteorological maps, geospatial maps, they can also be maps of knowledge. I find things like conceptual models, so meteorological conceptual models are also brilliant things, but also process description. So you may have heard, for example, of the forecast funnel, showing how things fit together. That kind of thing is really quite helpful. And it's going to help the students feel motivated and confident with what they're going to learn next. So some more further online ideas, so show and tell, getting people to show examples from their own work, building a glossary, conceptual model, so building maps, doing this sort of thing, or pre-course assessment and reflection exercises. So now in our class, we have a group of students whose knowledge is activated. They know what they know what they don't know, they know what they can do, they know what they don't know, can't do. And you'll also notice that it was a very active step. This wasn't just passive. So already our course has taken on quite a participatory nature. So what we'll do, we'll skip over to see if there are any questions on the Slido. Rosa, if you don't mind to share, and we'll see if there are any questions. If there are no questions, that's okay. We can skip on back over to the slides. My understanding of the real world problems can be outdated. Somewhat worried as I teach obsolete skills. Actually, in our world, as things move on really quickly, so we're living in a world where there's much more observation available, a lot more numerical weather output available. This is for those of us involved in meteorology, but the same is true across Earth observing and Earth system science. It is quite hard to keep up. Things like those satellite enabling skills can be really helpful to help you do that. So I'd offer you the encouragement of actually, if you're feeling slightly out of date, that kind of is okay because it keeps us honest as teachers. It keeps us thinking, okay, am I really doing the best for my students, which is a good thing to be doing, to have that critical reflection idea. The focus of the training seems to be on problem solving. Could it not be used to suggest to inspire ideas without a particular purpose? Yeah, I think you can use training to do that. It might be a slightly different thing. Maybe this is inside a university course. So the framing of what I'm doing here is teaching particular skills. So, okay, what are the skills that the students need? And let's work in a very participatory way to teach that skills. There are other environments where we can teach to inspire. To show examples, and you're going to have to look in your course to see if you have the right balance. So you might have a university, for example, survey course that looks at the cutting edge of a particular discipline. So actually looking at Earth system science to actually get people to understand what the edge is. Now, of course, you can still use these principles to teach that way, to actually, so you're still going to activate the student's knowledge, demonstrate what it is you're actually wanting to do. If you're doing that survey course and looking at the edge of Earth system science, what is it they're learning and what demonstrations might you yet have? So you can still do that kind of thing. But you're right, I'm taking a particular skills-based professional development focus in this particular presentation. Can I get the next question, please? Broadening worldview perception, just 5 things, recall, memory, enriching task. So I think, is this an example of a way of teaching? I'm not quite sure. So maybe if that person, if you could reply to your own question, you might be able to provide a bit more context, and maybe that's something we can discuss at the end.
Mark?
I am afraid we lost Mark for a second.
I think he will return in a moment. Meanwhile, we may perhaps look at this question: any strategy to cope with a highly diverse student skills? At least in my experience, that's some ways that we have used is to group the students in according to their skills, maybe use some pre-course activities or quizzes to see where their skills are, or maybe introduce them with some pre-course resources that they need to go through before they attend the course, and that will then ensure that we have students with at least the minimum skills? What do you think, Madalina?
That's a good reflection. I think that the diversity of student skills can be both a challenge and an opportunity. I think Mark is now unmuted. I wonder if he hears us again. Mark?
I do, yes. Sorry about that. Not quite sure what
where
happened.
were you? Were you scared by the question?
There was a big bridge. I went under a bridge.
All right.
So,
okay, so maybe we continue then with the presentation and we go back to questions a bit later.
Would that be okay? Does that make sense? Or was there a particular question you were addressing just then?
We were just talking briefly with Vesta about what happens when there's a large variety of, so a difference in the skills that the learners might have. Any tips for that?
Love it.
Do you have any ideas?
So differentiated learning. I think this is a really important thing. And I think it's something we've seen in many of our courses. We should almost take it for granted that there will be a variety of skills in our courses. And it's something that we'll maybe get onto it when we talk about the application of knowledge. But actually, I'm a big fan of getting students to work together. And this is partly where the differentiated skills can come in. So some students will be helping others, and people will be maybe learning more or learning the skill in a little bit more depth, and some in less depth if it's the first time they've actually come across it. So this kind of differentiated learning approach. So I think you will pick that up when we get to apply, if that's all right.
Yeah, that's an excellent point, and I think there are opportunities in online that are particularly addressed to this issue of what do we do in order to personalize a bit of learning when the skills are very diverse. But let's get on with the presentation for now.
Okay, so now we get on to demonstration. So here's a little screenshot. This is from a little online demonstration video we have of teaching people to use NetCDF files. So in demonstrating, we're showing the task, and we're working with the actual task because we can, or we're working with a synthetic portrayal of the task. So for example, we might be working with a simulator, and there's an example of a simulator on the Padlet. So this is where we can't show the full meteorological display system, or for whatever reason, or maybe our classroom or our online environment isn't fully set up to truly represent the depth of the task or the problem. And of course, we're relating the steps to the integrated task. So here's a poll. In your courses, who does most of the work in the demonstration steps? So this is quite a quick poll. The poll is open, slido.com, code EUMSC3. Let's see who's doing most of the work in the demonstration step in your courses. Please do be honest. Rosa, over to you. So is it all the teacher, mostly the teacher, but some of the student, mostly the students, some of the teacher, or all the students who are doing the work during this demonstration step? All right, take another 10 seconds or so. Three, two, one. Let's see the results. So mostly the teacher, some of the student, 16, 17% of you, all of the teacher, mostly the students, some 10%, all the students 4%. And again, there isn't a rule for this. Personally, I tend to go towards mostly the teacher, but quite a lot of student work at this point. But we'll get into some subtleties about what do we mean by teacher. But this is, again, it's a question for you in the demonstration step. Who's doing the work? And is that the right person at each moment in this demonstration step to be doing the work? All right. So let's jump back to the slides. So obviously your demonstration is going to be consistent with your goals. And so if you're teaching tasks, it's going to be about the task. If you're teaching procedures or behaviors, it's going to cover that. You're going to direct your attention to what matters. And you may actually run multiple demonstrations and then compare them. And you can get the students to do the comparison. And your tools are going to suit your application tasks. So you might be using software tools, software notebooks, or online labs can be really, really useful at this point. So your demonstration can be just showing your students what to do. If it's a forecasting task, you can walk through it and show them what you're doing at each step. But I think you do need to have some interaction moments where you're actually checking that your students have understood what you've done and that they're appreciating the important point at each step. So if you're going through a forecasting process, maybe it's a daily weather exercise. At the beginning where you're developing a synoptic analysis, what data are you using and why? And you may be saying so actually, right, show a display, show a screen capture, and then ask the students what is there and why. Some of what we do, we use a lot of the things called Jupyter notebooks. So there's a software notebooks. This is an example of one. This has got Python code in it. It's got the actual output from the Python code. This is live. If you change that code, you will change the output. And it's got some instructions. And for code and scientific-based courses, this can be really useful. And so these are demonstrations where what you're able to do is give the students a notebook that takes people through an entire processing chain or set of steps so that they can then see each step and actually, in a way, do each step. So they just hit return on each step and they'll then see what the output is. Hit return on the next step, see what the output is. So they have a live and real version of the process that you're teaching that they can then build on in their own, in the next steps in the course and in their own work. So the demonstration step, we often start with this step, but it's much more than a presentation. And there should be a lot of consistency with what we'll then do in the activation and the application, I shouldn't say activation, the application step that follows. There's some nice notebooks on teaching with Jupyter. So for those of you who are teaching software, it's a very straightforward set of tools to use. And that link will take you to a set of notebooks called Teaching with Jupyter. The thing I've just shown you is one of the simplest forms of teaching with Jupyter, which is called Shift Enter for the win. And what that means is you give people the notebook, they press Shift Enter, and they can see the result. From a student's perspective, this can be really quite exciting because what they're then able to do is they see that they have in front of them all the tools they need to do a job. This could be to produce a sea ice anomaly plot or a solar radiation anomaly chart, or to look at some atmospheric composition data, or to generate the air mass RGB and these other kind of things. So they can then see, okay, I now have all the tools I need to be able to complete this task. The next step is you're going to re-demonstrate and actually go under the skin and go, okay, right, did you see that in this moment, what actually happened? What channels did we combine? What data did we combine here? And actually drawing the student's attention to each step. We also use quite a few videos that demonstrate. YouTube is one of the second, it is the second most popular search engine in the world. And one of the most popular searches on YouTube is how to do something. Now, a lot of that is people my kids' age looking for Minecraft or other games and working out how to do stuff in Minecraft. But videos that teach can be really quite useful. I would suggest that in the classroom environment, you want to augment that with some Q&A. So actually, what did people notice as they went through the process? What was hard? What was easy? What was important? What didn't matter? Was there anything in particular that they had to pay attention to? Is there anything that you need to draw their focus to as they go through that process? So that's the demonstration step. You'll see on the Padlet in the Moodle site a couple of other examples of ways of doing demonstration. But now we get on to the fun part of the course. This is the bit I really like. And this is where we let the students actually work hard. So this is an example from a remote sensing course that was in Cluj in Romania, I think. Yes. And what we're seeing here is a classroom, and we're seeing lots of people staring at computer screens. A few people walking around, they're probably the instructors. And what's to notice here is that quite clearly in this environment, it's now the students that are doing almost all the work. They're very likely here working in pairs or groups, which is quite an important part of this step. So, your course already has lots of participation because you've generated that in your activation and demonstration step. Now they're going to do even more of the work. They're going to have their first attempts to apply what they've learned in the demonstration steps. Really important here is that mistakes and reflection on those mistakes is really a huge part of the work. And there'll be lots of artifacts, stuff, bits of work happening. It could be more maps. It could be more Jupyter notebooks. And what's going to happen is your students are going to make mistakes. And the trick at this point is to help them think through what they did wrong, to reflect on it. Well, first of all, to identify it and then reflect on it and work through them rather than just tell them what the answers are. So you're going to be working on problems, and more problems and lots of practice. And the variety of the problems you give people is going to be the variety that relates to the real world challenges they're going to have to face. And this again comes back to your learning objectives. If this is an entry-level course, you might have a constrained set of problems because you're trying to teach your students to only forecast for certain meteorological phenomena in certain regions, or only identify certain narrow bands of features in imagery. There's going to be less support or scaffolding than in the activation and demonstration steps. Your students are doing much more of the stuff themselves. Again, lots of artifacts being produced. And reflection and peer and instructor, there's corrective feedback, are really important. So by reflection, I mean people being able to identify when they've made a mistake, think about what that mistake might be, to think about when they've actually succeeded and what led to that success happening, to be able to talk with a peer and discuss. And this is where I think the differentiated learning can become quite helpful. So you will always have people who are slightly more confident or a lot more confident working with people who are less confident or a lot less confident. And this is where the peer work can help. So the student who is less competent here will be then asking, okay, what did you just do then? How can I do that? What's the next step I need to do here? And your more competent student will be able to share their knowledge and teach. Now, that will actually help them cement their knowledge, because if you can teach it, then you do definitely understand it. So this is quite a nice element here. And also in some classrooms, you may actually end up with 2 or 3 little groups working together, where you're putting the students who are working on a constrained set of problems together and the students who are working on a broader set of problems working together. So you're able to flip it and actually have the more competent students and give them time to work together and develop their understanding much quicker, so that the questions and the challenges that that group come up with are going to be different to the other groups. So it's a standard approach of differentiated learning. It's used in classrooms around the world and can be really powerful. What it depends on is having your students working in small groups. Now, the challenge, it's going to be doing this online. So this is an example of the application step. This was from a climate course. This was, I think, over a 4-hour period, people playing with some climate data and then producing some artifacts. So just as you look at these, what you might notice is they're all similar in some ways. They're all using climate data, but they are also different. They're looking at slightly different geographic areas, slightly different regions of interest, and slightly different time series and slightly different parameters. All of those choices were based on the things that interested the students because of what their roles are. So you've got an opportunity here to allow the students to work on problems that are directly relevant to them. This was all done using a toolbox. This wasn't a Jupyter Notebook example. This was a thing, R Shiny, with the Climate Monitoring SAF toolbox. So the corrective feedback is quite an important part of this process. And what you're doing is you're helping the student progress rather than provide an answer. So have a look through your code and just check which steps aren't working if you're working in a Jupyter Notebook. Or have you looked at this particular place in the image if you're wanting them to do an image analysis? But you're not telling them just exactly what the answer is. The instructor role is a little bit reduced during this step, and some instructors do find this role difficult. If you're very used to lecturing, this can be quite a challenging environment initially. And then it becomes a whole heap of fun, because what you realize is the students are coming up with a million questions all the time, and you are getting to share your expert knowledge, but you're sharing your expert knowledge in a way that the students need it at that moment you're able to give it to them, which is great. The variety of the problems does need to match the variety of the real world tasks you're being targeted. And this is where in your course design, you might decide to actually narrow the range of problems you're focusing on. And that will be associated with narrowing your learning objectives so that you can actually teach. Or you may find, okay, we need to have a really broad range of teaching examples here because the students need to be able to forecast for a whole range of areas. Challenge in the online environment, finding the students who are struggling. So in a classroom, this is quite easy because you can see them. You look up and they look confused, or you catch their eye and they look a bit worried or not settled or something. And you can wander over and say, how are you doing? How do we do that in the online environment? So the poll is open again. And this is quite an important step. So I'm going to give you about 45 seconds to do this. Look at slido.com, EUMETSAT. In an online class. This might be in a Zoom environment, or it could be forum-based or something. How are you going to find the students that are struggling? So take another 15 seconds or so, have a think. So if you've got a forum-based course where you're asking people to submit stuff in forums, or you might have an environment where you've got lots of different breakout rooms set up, or chat. Okay. 8, 7, 6, 5, 4, 3, 2, 1. And let's see what we've got. Excellent. So the chat, actually having chat going, people not participating, looking confused. So if you have a Zoom, or if you're doing this kind of environment, you might have the videos on so you can actually see people looking confused. I think chat is a great thing. So some people have used Slack or Rocket Chat or something like that, or Zoom Chat or WhatsApp. So you actually have a little bit of vibrant conversation going on in some form of forum, and you notice a change in somebody's participation might signal when they're confused. Or if your classroom environment is set up in a really positive way, and this would be ideal, people can say, I am confused. Other things, they're not responding, they're not participating. So this you can also see in, if you've got a course environment, so something like Moodle, where you can start to see somebody's participation drop off, or they may even quit. And that's something that's worthwhile doing. So sometimes in some of our Moodle courses, we keep an eye on the student participation rate. And when we notice that some students' participation is dropping, but they're still logging into the course, we've had it in the past where we've had like a kind of a coffee room chat, and we'll chat with them when they're next in and just ask them how they're doing, if they need any help, and kind of reach out to them. So this is, yeah, asking them if they're having challenges, questions in the chat, questions, breakout rooms, not talking, all these kind of things. So you've got some great stuff here. One person saying it's impossible. I think it's not impossible. I think it's really hard. I think it depends on two things. One is setting up the positive emotional space in your course so that people feel comfortable to say, I'm stuck now. Giving them the channel to actually do that, be it chat or email or whatever the communication channels you've got set up for your course. But also having these moments of checking in, or these moments of being able to see how they are doing. So you'll notice as the students are producing their artifacts and doing stuff, their rate of production will slow down, or they'll look stuck. And this is also a place where if students are working together, they can help each other out. So the stuckness can be solved not necessarily by working with another instructor, but also by working with another student. Directly ask the students randomly. I quite like that, but be gentle, be kind, because obviously you don't want to upset the ones who are struggling. Yeah, but actually finding out, if you feel, I don't have a feel for how my students are doing right now, actually reaching out to them and getting information. Somebody's dropped on celebrate failure. I love that as well. That's about setting up the positive emotional space. So when somebody makes a mistake, particularly in this step, we're meant to be making mistakes. We're learning how to do stuff. So what's your mistake of the day? Post that in the forum. Lovely. So again, we'll take a screenshot of this and we'll drop it on the Moodle site so that we can see some of the things that might help out in this particular step. So let's go back to the slides. There we go. All right, so here's some online ideas. So using breakout rooms, if you're using something like Zoom or WebEx, you can actually set the students up into small groups and actually have them in synchronous Zoom meetings or whatever, and working in small groups. Actually having mini presentations, so every so often the students present back and actually say how they're doing and what they find out. Chat and forum posts, all is about getting artifact generation and sharing and reflection. So you're producing stuff, lots of stuff getting produced here. And in the group work, of course, the students can help each other. Okay, so that's where the students apply the new skills and the knowledge. Now, in many classroom courses that a lot of us teach, we lose the students after this step. They now go back to their home organization. In the online world, we can start to construct our courses so we have much more on-the-job training. So those of us involved in professional development training, this is the point at which we might be asking the students to do their job and just share the job with us. So this is the integration step. The students integrate their new skills into their day-to-day work. So this is an example of some SIGMET production. So a SIGMET chart over the Iberian Peninsula. So this is aviation forecasting chart. This is real world work. So what's going on is the students are transferring what they've learned into their everyday life. Might be formally inside the course, but it may be formally outside of the course. So it may be actually somebody else's responsibility at this step. And in your course design, you might be actually thinking, how do you work with that person, effectively your client, to see how the student's getting on? And online, again, offers this chance for people to share something from their daily work. So this is real on-the-job training. So we're no longer working with problems that are provided by the teacher, but problems that are provided by life. So you're doing the job with the new skills. That's good. And you should be able to reflect on what you're doing with your new skills, what you've learned, and how the new skills made the difference. Many of you may have an element of assessment at this point in your course. It might be a self-assessment, a peer assessment, or instructor assessment. And it may actually be a formal assessment for those of you who are teaching competencies and you're having to actually certify competence prior to people being formally allowed to work. You may, and I would suggest should, also see innovation. The students should start to adapt the skill to their working life. And the quality of the artifacts is now high. They're producing high quality stuff. So what this might look like, for example, if people are working with Jupyter notebooks and looking at satellite data processing chains, they'll be using the notebook that they first saw in the demonstration step, and that they modified during the application step. But now it's very much theirs. It'll be contextualized to their own region of interest, their time of interest, the parameters of interest. And it'll just be part of what they do. And this is one of the lovely things about having code that can be shared and reused. So on the EUMETSAT side, we use Creative Commons or MIT licenses. And this really allows us to provide code that people can use and adapt to their working environments. Quite important. So the artifacts will show the student's own creativity in their application, and of course the evidence of the effectiveness of the training. The students, they won't consider them artifacts, it's just work. I just did my job. It might be invisible to the trainer, and it may be part of your course. It's just to get people to share stuff from their work back to you. So what some courses do is they'll say, okay, the course is now kind of finished. What we'd like you to do in the next couple of weeks is share a couple of reflections and a case study from your work. And this will be something you have to do in order to earn the course certificate, but you're just sharing artifacts from your actual work. And this, in a way, is one of the strongest forms of evaluation you can do at the level of course. So you will, of course, be doing some form of, are you satisfied with this course? What sometimes gets called a happy sheet, where you ask the students on a 4-point scale, did you enjoy the course? Did you find it useful? Would you recommend it to colleagues? Was it well organized? All useful stuff. But at this step, to actually see the evidence of the effectiveness of the training is much more interesting and much more useful. And this is what it should be leading to, of course, the kind of the excitement. So if you remember at the beginning, we had the scream. This is what we're actually looking for, is the excitement of people actually using the skills in their actual day job. So that is the simplicity of Merril's framework. So that principle of teaching with underlying the problems that people face in their day-to-day worlds, and the teaching flow that goes through activating the student knowledge, demonstrating, applying it, and then this integration step at the end. Now, if you wish, we actually have a very short follow-on course. You can self-enroll. It's free to do so. It's a self-paced course for you to basically go through each of those steps. So for those of you who have a course that you are designing right now, my suggestion would be, we're really happy to have a cohort of folk travel through this, and you can use the forum in that course to talk to each other and share your experiences. And your task will be to complete a learning journal. So basically to design each step. So what problems are you going to work with? How are you going to do the activation step? How are you going to do the demonstration step? How are you going to do the application step? And how are you going to do the integration step for your course? Now, you're going to have to make your own choices because it's your course, but there'll be a few suggestions and things to think about. So if you wish to, you can go along to that course. It's also linked to from the short course Moodle site. So that's something for you to look at. And also on the short course Moodle site, there is a Padlet there. If you wish to post examples from your own experiences of the 4 steps and also teaching with problems, please do so. That would be fantastic. And you'll also see 3 little videos from Madeleine Ungar, who has just gone through some other ideas for teaching online to help you think about that. So that's me. We've come to the top of the hour, to 4 o'clock here in Central Europe. Thank you very much indeed for your attention. What we'll do now is turn to questions. We'll take a few Q&A, but we can stay for quite a while to have a wider discussion. So Rosa, if we can turn over to you. Awesome. So if we'll start at the top. So people have been upvoting. Let's start there. How to motivate forecasters to learn new skills, data, and products when they feel safe with what they have already learned and still use the same data and methods. I think this is quite a core and real challenge, and partly it's institutional. So the data and products that people tend to use in the forecaster environment are what works. Now, the forecaster environment is one that demands that people are consistent and follow the processes and procedures. So some of this is institutional and is about supporting people with rules to use wider data sets. What we found in some parts of the world, what works quite well is finding the forecasters who have a little bit more curiosity for new data sets or for new ways of working. In some parts of the world, they're identified formally. So in the US, they're called the Science to Operations Officers. And to actually work with that group to help them understand a new source of data or a new forecasting product. And they will then test that out and share it with their colleagues. There's quite a nice thing that can happen here, particularly with new data products, where the data product provider can work with a group of forecasters to get feedback. And what that does is also help the product provider to frame their product well so that forecasters might actually want to use it. And it also helps the forecasters, when they realize that somebody actually cares what they think, gets them more engaged in it. And then once you've got forecast stories, so case studies that actually use the data, you can start to share those around. So I think it's more of a change process rather than a single training course approach that may help here. Okay. So if we leave the diverse student skills for a moment, if we leave it up, what we'll do is maybe come back and other people may want to have a concept. Call 5 thing. Okay, right now the phenomenal learning. So start a learning session. This is a suggestion by asking the students to recall 5 diverse things regarding the subject. So actually getting people to express the edges, I guess, of their knowledge. It's quite a nice suggestion, particularly in the activation and demonstration step. So in the activation step, saying, okay, well, what do you know about this? Let's have a look in 5 areas around this topic. So if we're looking at fog, okay, well, name 5 different areas that we could look at with fog. An interesting idea. Thank you. Why a lot of training stops for integration? Who's to blame? Well, this actually comes, I think, down to the mandate of the trainer and the training organizations. So in EUMETSAT, we are a satellite operator and we teach people to use our data. But it's not our responsibility for forecasters to use our data, for example. That's actually the responsibility of the weather service. So what we shouldn't do as a satellite operator, and a helpful one, I'd like to say, is we shouldn't claim the mandate of the National Weather Service, but we can work with the Weather Service to check that our training is actually helpful. So in this case, if somebody comes on one of our courses, so let's say it's a forecaster from one of the Nordic countries, so let's say they're from Finland or Sweden or Norway, they'll come on one of our courses, and these are courses we organize in partnership with the weather services in those areas. We'll do some teaching together, but the integration step will actually happen when the person goes back to work. And that's where the local weather service has responsibility to make sure that that person is able to do the job and they can actually implement the skills. But we'll get feedback from the local weather service, the National Weather Service, that helps us to then design the course better. So there should be a feedback process. So for those of you who have a limit on your mandate, so in other words, it's not your job, what this comes down to, I think, is the ability to relate to the organizations that you're trying to serve and actually helping them to see what your role is. What you may also want to do is some form of impact assessment. So something we did a few years ago, we asked, in fact, it was Madalena, she phoned round all of the EUMETSAT member states and tried to speak to the head of forecasting or their representative to ask them how our training was helping them or not, or at all. And to actually get that kind of feedback from people is quite a helpful way, I think, to understand how your training is being useful. The other thing you can do if you're feeling particularly committed is, of course, work with the local weather service, National Weather Services, to say, well, actually, how about if people provided examples from their work back to us, and we could then assess that and have that as part of the certificated process. All right, thank you. So how to deal with evolving mindsets from the student community in general that wants to retrieve any answer promptly and in very short form. So this is the ability to get information quickly. I think that's a skill. But I think the interesting part of this skill is being able to reflect on the quality of the retrieved information. So I see a lot of people challenging the use of Wikipedia in classrooms. I'm a big fan of people using Google or Wikipedia to find answers. It happens a lot in our world in science, particularly in computationally based sciences. People quickly Googling stuff to find the answer. And I think part of the skill we need to teach is people's ability to reflect on the quality of the result they're getting. Have they got a good result? So that's fine. You can retrieve any answer promptly and in short form. But now how are you going to assess that that is a scientifically helpful thing? I think the other thing is if you're getting people to work in the application step, they're actually having to then apply this knowledge. So yes, they're able to get it quickly, but now use it, make a difference. Or do you need some more deeper understanding in order to be able to work with what you're doing? And that's where things like maybe the notebooks are quite helpful, because people can get a result quite quickly. And we've seen this in maybe some of our climatology courses. You'll get a result quite quickly. You'll plot an anomaly map. And then we see that people then go, hold on, I don't actually know what my science question is. And that's really helpful. You know, why am I looking at this particular anomaly map? Why is this a useful thing to do? What is it I'm actually trying to achieve? And that we can now start to do much deeper work with. All right. Is there another question? Motivating professionals is hard. Yes and no. Yes and no. I think some of what we maybe do as trainers is it might be helpful if we sometimes understand what we're doing is actually helping facilitate change. So it may be that what's not needed is a change, a training course, but actually a change process. How do we get people to do something differently in the forecast office? May actually not be a training question. There might be training as part of the question, but it might actually be a richer change process that we need to think about. And that is, you're going to have to think about, well, how does change happen in the environment you're thinking about? So I think in a forecasting environment in particular, where you've got professionals, change does happen, and it comes about, I think, through people talking to each other and reflectively, critically reflecting together, particularly after meteorological events. So actually people talking about how that forecast went. And it's quite an internal conversation to the forecast office, but I think that's where a lot of change can happen. And that's where you can get the motivation to get people to learn new stuff from. I think if the learning is very abstract or people can't see how it's beneficial, then there's a challenge. And I think so for something, for us, for example, as a satellite data provider, we can quite often get excited about a new product that everyone needs to use in the forecast office. And of course, that's never going to work because it's yet another product to go in the display system to overwhelm an already busy display environment that may or may not fit in the forecaster's mental process. So what we're starting to see now is a lot more use of things like test beds, where we'll take a new product, we'll get a group of forecasters together, and we'll do this in the summer convection season, and we'll say, okay, well, let's see how this goes. So the European Severe Storms Lab, ESSL in Europe, this is part of what they do, and there's an equivalent in the US. And they will then evaluate a product and see how it is useful. And the changes might need to be changes to the algorithm of the product, or the way it's displayed, or maybe the way that the value of the product is articulated to forecasters. And this kind of thing can really help people to then understand how to best put the product into the training environment. So yeah, motivating professionals is hard. I think you need incentives, but you also need validity, real world validity. Does this thing help? And that can be a big part of that. Okay, thank you. Question from BKMG. Is EUMETSAT ever teach open satellite data and GIS software? So we do that a little bit. In the sort of environment-based courses, we're more using Python and R as the two frameworks that we're using to teach the application of our data. But I think GIS software is actually more broadly understood as in a geospatial way of thinking. So if we look at our data, the EUMETSAT data, we've come from a meteorological heritage. We're very used to looking at our data within a meteorological display system. The GIS heritage is slightly different, and it's quite interesting when you take a GIS person and show them a meteorological display system. They don't like it because it's come from a different heritage, a different framework, a different perspective. And that can be quite a challenge. And it's quite interesting seeing that happen. So we've got a colleague, Ilaria, in our place, and having seen her look at data has helped me see our data differently. So I think, yes, GIS is a future for us, but we use Python and R at the moment. All right. So I think that's probably taking us to the end of the questions in Slido. What we can do, should we try some chaos? And if we allow,
Mark?
yes.
So before we go to the chaos, I just wanted to wrap it up a tiny bit for those that have to leave.
Yes.
Okay. And maybe we can also stop the recording before we